Alrighty, let's get started. So with this video, we're going to continue discussing significant figures or significant digits. Last time, just to review, we saw that a number, let's say 4032.10, when you express a number in science, you have to let the person who will be reading this or using your work or whatever know how accurate this particular number is to the actual value. Because usually in science, you're doing some experiment, you're making an observation, and so you're probably using some device to measure, maybe a ruler or a force probe or all sorts of different things. And so you're going to give the result of your observation or your measurement. However, these measurement devices are not perfectly accurate. With a ruler, for instance, you have a certain grading on the ruler, a certain number of lines that tell you, oh, this is the 1 inch mark, this is the 1.25 inch mark, this is the or centimeters, this is the 10 centimeter mark, 10.1 centimeter mark, and so on. But if you need to get more accurate than that, then you're guessing the rest of the digits. So for instance, if you measure with your ruler the length of let's say this can of soda or something, and you measure it to be, I don't know, let's say 10.1 centimeters in height, but you're like, oh, let me see if I can get a little bit more accurate. I think maybe it's actually 10.15, because it's a little bit more than 10.1, but is it 10.5 or 10.15 or 10.16 or something like that? I don't really know. So to express the fact that this last place over here, I'm kind of guessing, I know it's more than 10.1, but not exactly how much. To express that kind of uncertainty, you cut off that last digit, or you express your number, your measurement, to the most significant digits. You'll still put this extra digit there. So let's say when you're writing down your answers, you'll write down 10.15. However, you're going to note that, sometimes you'll see something like plus or minus 0.01 centimeters or something like that. That's kind of the error correction type things going on. Well, when you express this to someone, you need to let them know that it's not exactly 10.15, it's somewhere near it. Furthermore, it's not just that, because it's like, okay, well, this is, meaningless to me. Who cares if I'm perfectly accurate? I'm just giving my measurement and whatever. Well, it is important, because then let's say you're going to be using these measurements to make calculations. Maybe we want to figure out, if I were to stack 150 of these cans on top of each other, how tall will that stack be? Well, now that little uncertainty is going to be compounded as you add more and more and more on top of each other, and it becomes more and more relevant. So that's going to be the plan for today. We're going to look at the rules for when you take these significant digit type numbers and you start to do operations with them. You add or subtract, multiply or divide, things like that. But as I was saying, let me go ahead and review the rules for significant digits. We had basically 3 big rules. When you have a number sitting in front of you, how do you know how many digits are significant? Well, the first rule says any non-zero number is significant. Okay, so for instance, for this particular example I wrote up here, 4032.10, the 4, the 3, the 2, and the 1, those are all non-zero numbers, so those are all definitely significant. So there's at least 4 so far. Then we have 2 more rules. The first rule is for instance, the zeros. We took care of the non-zero numbers. What about zeros? When are zeros significant? Well, first, If the 0 comes between two significant digits, then it is also significant. So for instance, if 0 is between significant digits, it is significant. So this 0 between the 4 and the 3, that is also a significant digit because I know it is exactly 0. It's not that I'm guessing what that digit is, it's definitely a 0. What else? Well, another rule for zeros says that if a 0 comes at the end of a number after a decimal point, it is significant. If a 0 is a trailing 0, so that means it's the last digit, there's two pieces, right? There's two rules for this. It is significant if after a decimal point, and it's significant if before the decimal point explicitly. And I have to be very clear about what I mean by this. So first, the first part of this, if you have a 0 as your trailing digit, so that it's the last digit of your number, and it comes after a decimal point, then it's significant. So this 0 right here, that is significant. It comes after the decimal point, and it's the last digit. This other piece says significant if it's before a decimal point explicitly. So an example of this would be something like 4,030 point. So the fact that I wrote that decimal point there tells me I know this is exactly 4,030, and it's not that I'm kind of rounding it to 4,030. Okay? Now, any other 0 other than these two cases, the red and the green cases, are not significant. So for instance, if I had 0.01, notice this 0 here comes before an explicit decimal point, but it's not a trailing 0. It's not the last digit of your number. He's not significant. This 0, also, it comes after a decimal point, but again, it's not a trailing 0. It's not the last digit of your number. He's not significant. Now, if I had 4.01, this 0 is significant because it's between the 4 and the 1. Also, if I have, let's say, 4,030, that is not significant. That last 0. The first 0 is, but the last 0 is not because we don't have the decimal point at the end here. Better not write it like that. There's no decimal point shown explicitly, whereas in this example, the decimal point is shown explicitly. All right, so that's what we saw last time, the three big rules. All non-zero numbers or digits in your number, they're always significant. Now, if you have a 0, there are some cases. Number 1, if it's a trailing 0, that is, it's the last digit of your number, and it comes after a decimal point, it's significant. And if it comes before a decimal point, and the decimal point is shown explicitly, it's significant. And then, of course, the other big one for the zeros is if the 0 comes between two significant digits, then that 0 is also significant. All right, well, now what we want to do is, what if we're trying to add two numbers together, and we want to give our answer, but this answer needs to show, what are we sure about and what are we just rounding at the end? So here's the two rules. I'm going to do a rule for addition and subtraction. And then we're also going to have a rule for multiplication and division. All right, so for addition and subtraction, the rule goes like this. When you add numbers together, the final answer should have the same number of decimal places as the number with the least number of decimal places. Okay? So, the rule says answer has same number of decimal places as the number in the problem with the least decimal places. Now, what does this mean? Let's say I have something like this, 6.22 plus 53.6. I want to add these two numbers together. Okay. I've, of course, aligned them using the normal long addition type way we learn in grade school. So I add these to 2 plus 0, that gives me a 2. 2 plus 6 gives me an 8. Then there's the point. Then the 6 and the 3 is a 9. And then the 5. So when I add this without thinking of significant digits, I would say the answer, of course, 59.82. However, now that we know we have to be careful about such things, about significant digits, I now have to use the rule. And the rule says the answer should have the same number of decimal places as the number in your problem with the least number. So I look at my two of decimal places. I look at the two numbers that I added. This one here has 2 decimal places, and the second number only has 1. So I know because the least number of decimal places in my problem is 1, this guy had 1, this guy had 2, then I know my answer can only have 1. So the actual answer would be 59.8. I can't write that 2 because I don't know that it's definitely a 2. Because the 53.6 itself, I don't know the accuracy of his hundredths place. Is it exactly 53.6? Then there should be like 53.60. But I didn't write 53.60, I wrote 53.6. So I'm only sure up to the 6. I don't know the rest of the places. So the fact that there's a 2 in the other number there, who cares? Because should that 2 be added to 0 or to 1 or to 3? I don't really know. All right, as another example, let's say I have 14.311, and then I'll have 45.09010. And I'm going to add these. All right, so just like before, what do we have? So 0, this is a 0, this is a 1. 1 plus 0 is 1. 1 plus 9 is 0. Carry the 1. 13 plus 0 is 13. 3, carry the 1. 14 plus 5, with a dot here. 14 plus 5 is 19. Carry the 1. And 2 plus 4 is 6. So, in grade school, I would say the answer is this big old long number. However, now I have to look at the number of decimal places in my problem, and then my answer should have the same number as the least. So my first number here has 1, 2, 3 decimal places, and the second number has 1, 2, 3, 4, 5 decimal places, and I do count that 0 at the end because it's written explicitly. Okay, so it counts as a significant digit. So 1, 2, 3, 4, 5. So this guy has 5 decimal places. So my answer has to have the same number as the smallest of these, which is the 3. So it'd be 69.301. And the same goes for subtraction 2. You subtract 2 numbers together, or 10 numbers together, or 150 numbers together, whatever. You get your final answer, and then you're going to round it based on this rule. You look at all the numbers you added or subtracted together. Look at how many decimal places each number had. Whichever one has the least, that's the number of decimal places your answer needs to have. All right, now multiplication and division is a little bit different. It's kind of similar if you're not careful about the wording, but it is different. It says when you're multiplying or dividing numbers, the answer should have the same number of significant digits as the number that you're operating with, the problem numbers, the same number of significant digits as the least number of significant digits in your problem. So answer should have the same number of significant digits as the number with the least significant digits. Okay, so notice the difference between these two. They're very similar. For addition, it's the same number of decimal places as the number with the least number of decimal places. So it doesn't say anything about significant digits. It says how many decimal places do you keep. But for multiplication and division, now you worry about how many significant digits there are, not how many decimal places. Okay, so here's an example. Let's say we have 503.29, and we're going to multiply it by 6.177. All right, now just to save some time, I'll get out my calculator and multiply these things out. I get 503.29 times 6.177, and I get the number 3108.8233. All right, so again, if we were in grade school, school would say that's the answer to this problem, and you'd box it and you'd be done. However, because we need to worry about significant digits, I have to round this answer. But how many places do I round the answer to? Well, it's not like addition and subtraction. I don't look at how many decimal places. For instance, this first guy has 2 decimal places, the second guy has 3, so I don't round it to 2 decimal places. Instead, what I do is I look at how many significant figures each number has. So the 503.29, that's 1, 2, so the 5, the 3, the 2, and the 9, they're definitely significant. The 0 is also significant because it comes between the 5 and the 3. So that's got 1, 2, 3, 4, 5 significant digits. My second number, they're all non-zero, so they're all significant. 1, 2, 3, 4. So this has 4 significant digits. So my answer needs to have 4 significant digits. Okay? Whichever number has the least number, that's how many I need in my answer. So I have to round this to 4 places, or 4 digits, not places. So it's 3109. I can only have 4 significant digits. The 3, the 1, and the 9 are significant. The 0 between the 1 and the 9 are significant. So there we go. I don't put the decimal place. I don't have 4 decimal places after the decimal. That's addition. For multiplication and division, it's how many significant digits. So just as a second example, let's say I have 25 times 4. Let's say 25.0 times 4. All right, so let's multiply these out. I get 4 times 0 is 0. 4 times 5 is 0. Carry a 2. 4 times 2 is 8, 9, 10. 1, 0, 0. All right, so in math, math class, we would say the answer is 100.0. However, we now use our rule, and we say the first number has 1, 2, and then this 0 is also significant because it's a trailing 0 that's after the decimal place. So this number has 3 digits, significant digits. The second number only has one significant digit. So my answer can only have one significant digit. So the answer is 100. If I were to put the point, so if I wrote 100 point, that's 3 significant digits. Because the last zero, well, first of all, the 1 is significant. The last zero is significant because it's a trailing zero with an explicit decimal point. And then the middle zero is also significant because now it's between 2 significant digits. So this has 3 significant digits. That's bad. This one only has 1 because those 2 zeros at the end are not significant. The last zero is a trailing zero, but there's no explicit decimal point. The middle zero is not significant because it's not between 2 significant digits anymore. It's between 1 and a non-significant digit. So there's the rules. Anytime you're doing, real science in a laboratory or calculations or whatever you happen to be doing, when you give your answer, you have to keep these rules in mind. If I'm adding and subtracting numbers, my answer has to have the same number of decimal places as whichever number I had the least. Whereas if I'm multiplying and dividing numbers, then what I do is I multiply it all out or divide it all out, get an answer, and I round that answer to have the same number of significant digits as the number with the least number of significant digits in the problem. Okay? Addition and subtraction, decimal places. Multiplication and division, digits. All right. So that's the video for today. We now know everything we need to know basically about significant digits. Number 1, what are the rules to figure out whether a digit is significant or not? Once we know, how do we use these numbers and operate with them to get answers? And how do we express our answer? We have our 2 rules, one for addition and subtraction, and one for multiplication and division. All right, I hope this was helpful, and I'll see you next time.